exercise lab. So we are going to have the presentation that summarizes your page 1, page 2. So each team will have the 5 minutes. So it's going to be around the 30 minutes or the 30 to 40 minutes if that works well. So no more than 5 pages, the PPT file. Okay, the due date is the this Sunday. Okay, the end of this weekend. Before we start the exercise lab on Monday, I should have the whole presentation. I'm not going to accept the file just before class begin or during the presentation because it will take a time to copy and translate. So only those who submit on due date will present. So this is the order. So why don't you check your time? On Monday we will have the group 1 through group 7. Okay, and Wednesday we will have the 8 through the 14th. Okay, so each team will have the 5 minutes. In your presentation, you can put the summary of your page 1 and page 2, which means the topic and motivation and the ER modeling and the relational schema diagram. Okay, and what is the idea and the possible query in English, as well as if you complete already the relational algebra, you can show the both of them. Okay, however, you cannot show the all details of your the project because you have a very limited time, 5 minutes. So please try to do your best to show the best way within 5 minutes. Okay, question?
Yes, phase 2 is very technical because we're using the EER diagram and the relational schema. So how are we supposed to talk about that?
Also, you can show the ER diagram or the ER diagram as well as your relational schema diagram. You don't have to show with how you convert this one. It's you have already done in your project. You can just show this is the relational schema diagram that will be used for your step 3 and step 4. Okay. Any other question? So if you are not ready, I'm going to skip. You will lose the chance to discuss about your project. Okay, so please try to do your best to prepare. I don't think it will take a time. You can just copy and paste because you can have only the 4 or 5 pages. One is for the topic and motivation. Another one is a ER diagram or ER diagram. The third one may be the relational schema diagram. The last one is a query and the relational algebra expression. You don't have to put all the query. So just to show the sum of them, 2 or 3. The query in English and how you create the relational algebra. That will be pretty much enough to see the overview of your project. It's the interim presentation. It's not final presentation. Okay. So I'd like to have a time for your final presentation at the end of the semester. At that time, you will demonstrate your entire project application. Okay. And please submit your PPT file by Sunday. Then I'm going to put all your file into the computer in the lab. Okay, then we can quickly start the presentation, then followed by the SQL exercise lab. Any question? Okay. This is a group presentation, so you can. I don't think it's a good idea to take turn in the middle of your presentation. One can be in charge of the controlling the PPT file, or then another one can present. It's totally up to you.
Will there be questions after we're done with the presentation?
If I have a question, so I'm going to have a question, even the audience can have a question, but it will be very short question and answer time. So today we are going to continue the SQL part. The last class we learned how to create a table. Okay, so which is the DDL data definition language. Today mostly we are going to talk about how to select the data from the relational database model, which is called the data manipulation language, DML. Okay, so before we start the SQL, the select statement, we already learned very basic the structure of the select statement, that is the select from where. Okay, so select from where these languages are from the relational algebra operation. So using the relational algebra operation, it's not very difficult to understand this one. However, there are slightly different things between the relational algebra and the SQL. First thing is the relational algebra output of the relational algebra operation is what? It's also relation. It's a set of the data, and also which means we are not going to allow duplicate data. So automatically the duplicate data they will be eliminated. However, SQL allow duplicate data. So sometimes it's called the bag of the, so just bag of the data or multi-set, which means there exists duplicate data. Why? Why the SQL allow?
Because sometimes we need those data.
Yes. So if we automatically eliminate delete the duplicate data, user complain, I need all the data listed. Okay. Then in our application, we try to manage it. Sometimes we can order and we can eliminate. There's the keyword that can eliminate the duplicate data in SQL also. So it's much more flexible and customizable. So because of that, we allow such a duplicate data. Also, in terms of the bag, the ABA, BAA is not different. Okay, it's the same thing in the relational relation does not allow here, but does not allow the duplicate data. But BA and AB are the same because it's non-ordered as long as you have the same the data. Then we will have the select from where you already know. Very popular the statement clause. We have select, so select attribute list, column list. List of the column, and from is the data source, it's a table name or a relation name, and where is the condition. In this case, the select and from are mandatory. So if you miss one of these, it will be error. However, where is the optional? In case you have a condition, what kind of condition we have?
For example, if like the
Select condition.
the salary more than $5.
Yes, that's the select condition. That is this one. And what else? Join condition. We have the join condition. So this where condition can keep the both select condition and join condition. You don't have to specify the specific option. However, there is another SQL standard that can include the join condition in from clauses. Either way is fine. We will see the both of them, but most popular right now is we can put the join condition in where condition. Okay, so that is the overall thing. Then we will see details of that. As a user, we are going to use the company database. So I believe that you already keep your mind the structure of the company relational database schema, as well as this is called the database state. After you populate the data, we have the schema, as well as the data instances. That is called the database state. Anyway, in your project, your goal of the step 3 is to build the database state. Based on your design, you will create the schema, and then you insert the data, populate the data. So we are going to select the data from this company database. Okay, so there's nothing we can discuss more. So we can use the select from where clauses to select the data. So first thing is retrieve the birth date and address of the employee whose name is John B. Smith. It's the first relational algebra. In terms of relational algebra, first we need to decide the relation, the data source. What the relation do we need to retrieve such a data? Employee is enough. So employee. Employee, then employee whose name is John B. Smith. This is a condition. What kind of condition? Select condition. And then we are going to retrieve birth date and address, which means we select the first name, John. This is the only case-sensitive data in relational algebra and the SQL. There's no case sensitive except the data itself. That is the reason it's a single quote or sometimes double quotation will be used. John and middle name initial B and last name L name is Smith. Then this is the project for first day and address. This is the reject. Okay, this is our relational algebra expression. This can be easily converted to the SQL. As we have seen, this is the relation name goes to the from. So this is go to the from, and selection condition goes to where condition, and projection goes to select list of the attribute. That's it. So that is the SQL. So very pretty much easy because we already covered the how to access the data using relational algebra. This SQL is just implementation of relational algebra expression. And we use this one in computer language, computer stuff. Okay. The next, retrieve name and address of all employees who works for research department. We already did this relational algebra expression. Okay, there are different ways. So you make the one employee DPT. You can join two tables. The join condition is D number, D NO in employee is the same as D number in department. Right? It's a join. After you join, and we need a research department only. So you can select D name is the research. Okay, then we need the name and address of all employees. We can project list. Yeah? The others are just straightforward. Employee and department goes to here. Join condition goes to here. And research goes to here. And the list goes to here. That's it. That is the sequence. That was the reason we discussed the relational algebra expression first. Okay, then the sequel is just nothing but implementation of the such a relational algebra and relational algebra operation and relational algebra expression. Somebody may be curious, is there any difference between the selection condition and join condition? No, you can use combined with the logical operation. You don't have to specify. However, in the SQL standard, SQL 92, rarely used, but still some of the database, the developer use the join condition in from close. That is the, we will see example about employee join with the department with the join condition like this. Okay? So we will see example later, but this way is preferred to use. Okay, so what about the disk query? We already saw the disk query. This is exactly the same thing. So we can do the relational algebra expression. At the time we had three relations tables. So it will go through here. And there are how many join conditions? In case three table join. Always n-1. This looks like the easy and obvious, but in real query, when you develop the database application after graduation, you join the database project, sometimes you need to join 5, 6, 10 tables join. So easily forgot one of the join condition, then it will be disaster. Why? For example, we join the 10 tables, but you put the 8 join condition. What's going on? It will be ambiguous. Cartesian product. Cartesian product is nothing but without join condition. It's an old combination. So think about the Cartesian product. You join the 1 millionth of the tuple and 1,000 tuple. How many tuple? 1,000 million. So it will take long time, never ending, really. Okay? By missing only one join condition. So always check how many table, 1, 2, 3, and how many join condition, 2. Then select the condition. Also, one more thing, don't forget whenever you code on your the editor or on your handwriting, so semicolon. So end of statement. Don't forget the end of statement. Then so this will return this query. Okay.
Professor,
Yes.
so what happens if both of the table have same name of the columns?
That's a good question. So what if we have the D number, okay, from the project. D number, department. That will be fine when you design. You can use the same name of the column from the different table. But when you join, can you differentiate? So it will be problem. So to address that problem, we have the aliases. So we can make the nickname. We can make the alias for the table. For example, in this case, think about this query. So this is a good example to how to address the conflict name, the attribute name. So for each employee, retrieve the employee's name and the name of his or her immediate supervisor. What does that mean? So from the employee, we'd like to list up. So in this data, we have the employee. For all employee, each employee has a supervisor. Okay. However, the top of the rank, like the James, probably CEO. CEO may not have the supervisor because of that. It's not. Otherwise, John B. Smith, his or her supervisor is a 3344555. So 3344555 is a Franklin 1. So list of Franklin 1 for this tuple. And next, 888666555 is here, the James Ball. So which table are you accessing? Employee only. However, one employee is used for employee information, supervising information. Another one is used for supervisor information. Okay? So it looks like the access of two tables, but actually that is the same thing. So how can we do that? In terms of relational algebra, operation, there is no specific, okay, no specific way to alias. Instead, how can we address that one? We can employ rename, EMP, and another one is employ for supervisor, employee, then join. How to join? Employees super SSN is equal to super SSN, super EMP's SSN. Okay, then what you need is what? Name. First name and last name of what? Supervisor's name. So super SS EMP dot first name super EMP dot last name. So this is the result. How can we make the SQL? Select from where this is the employee and this is also employee. Then to differentiate, we can rename. We call this is the SE. This one is S. Okay? So E means employee. S means supervisor's employee. Also, you can use without S. That means automatically alias. Also, to simplify, both of them are employees. So you can E and S. It will be aliased such a way. Then, what is the condition? super SSN. So super SSN of what? Employees. E dot. We can use the R dot attribute, the notation. So table name dot alias name dot super SSN is same as S dot SSN. This is the condition. Then list of what? Supervisors, first name, and supervisor, last name. So this is the way to address the conflict name, the attribute name problem. Okay. So we can use the alias for the table name. So we can use employee, alias employee, the department D name, or alias name E and S. Then E dot super SSN, S dot SSN, and specify. Also, if you want to rename the column name, yes, you can do that. What is that? In terms of the relational algebra operation, it's a row operation. So for the row operation, you can use S, Fn, okay? Or without the S. It will be, this name will be renamed as the Fn. When you list up the table, this query, column name of this data is Fn. Also, in your application program will recognize this column data as Fn instead of the E dot F name. Okay, that is the alias. So this is another way, the SESS, or without S, you can do that. But if we do not specify the where condition, which means that without join condition, without the select condition, is it error? No, it's not error. It retrieves all the data. So this one retrieves all the data. In case of department join, that means Cartesian problem. It's not the error, it's a Cartesian problem. Also, be careful when you have the multiple table, you can use the multiple column name, comma separate, okay, comma separate for the table. Question: what if we change the order of attribute? Any error? No, it's not error. Instead, just a different display. Okay, that's the only. What about changing the order of a table? In terms of output, no difference. It's the same thing. However, slightly, not slightly, it's a different, sometimes huge difference in terms of performance. DBMS mostly access the data from last one first. If you do not specify, or if the query optimizer is not working, okay, as a default, sometimes you can disable the query optimizer. That means automatically access the last table first, then this one, then this one. Okay. So this is a Cartesian example of the Cartesian product. It will show all combinations. So you should be careful whenever you use the Cartesian product. Okay. Then sometimes I'm very lazy to list up all column name, so we can use asterisk. What will be the order of this return data? Same order as you create. Okay, good. What about the employee department? It's a join, so it will list up all column of employee, all column of department. The order of the display is the same as created in employee plus as created in department. Okay. Then I wanna remove the duplicate data. So because the SQL itself is not a relational model, so it's not relation, which means the even duplicate data will be displayed, returned as it is. If we want remove the duplicate data, we can specify the distinct. However, you should be careful whenever you use the select the distinct. Why? So in this case, so duplicate data will be eliminated. So what about SSN? So output will be the same because SSN is already primary key unique. However, performance will be different. Why? Because how can you find the duplicate data?
Compare.
You need to sort the data. You need to do sorting algorithm. What if you have the 10 millions of data? It will take a time to sort the data. In this case, we have only 11 the employees, so it doesn't take a time. However, when you have the very large data, some of the developer instinctively put the distinct. Because some of DBMs, such as the SQL Server, usually when they provide the example, they select the distinct automatically. But distinct require sorting the data, it will take time. So not to use the distinct as a default. Only in case you need to check the duplicate data, at the time you can use the distinct. Okay. What about the set operation? So union minus intersect. So we can use the such a set operation for two. This is called one select from where is called SQL block. So this is another SQL block. So you can use the set operation for two SQL block. Be careful, as we learned in the relational algebra operation, type comparable. Same number of attributes. They should be type comparable. For example, if this is L name, it's not the error. As long as type are comparable, it will be written. However, if you have the P name PNO, but P name only, it will be error. So it should be type comparable. Okay? In this case, it will list up all of this and combine. Question? So output of this one, the first query block is a P1, P2. Output of the second query block is a P2, P3. What is the final output of the union? P1, P2, P2, P3? No. She said no. P2, one of them will be eliminated. In set operation, only in set operation, automatically duplicate data will be deleted. Don't be confused. In general SQL, no, it's allowed duplicate data. However, only set operation, they do not allow the duplicate data because it's a set itself. It's a set operation. What if I want a P1, P2, P2, P3? At that time, you can use union all command. Union all return all the data, not checking the duplicate data. So many of even the experienced developer, SQL developer, they confuse. So SQL always return as it is. No, except the union. So union automatically delete the duplicate data. So then next one is the query inside the query. Means we have one SQL block, but inside here, from here to here, we have another SQL block. Okay, query inside the query, that is called a nested query. So let's see the example retrieval name. So we already see how did we solve this problem? Join operation. We use the join operation, but what if this way? First, we will select the research data. Research data means what is the D number of the research? Forget about this part, only this query. So select the D number of the research department. Let's say that is the D number is 10. Okay? And submit another query. Select first name, last name, and address of employee whose DNO is 10. That makes sense. So this does not require direct join operation. Instead, it's the query inside the query, two query. Okay, this is called a nested query. Yes.
I see that you're using the number in.
Yes.
So
That's the next thing I'm going to explain. We don't know how many tuple will be returned for this, right? So it looks like this, but we are not sure how many data will be returned. So to address that problem, in is another set operation. Means, so for example, select exactly the same thing from employee where DNO in 1, 2, 3. As long as DNO is in one of these, that will be returned. For example, this can be converted into DNO is equal to 1 or DNO is equal to 2 or DNO is equal to 3. This query automatically converted to this one internally. So this is called in operation. It's a kind of set operation. When can you use? In case right hand side you are not sure how many of them. Okay? In this case we know department has only one D number. But like the PNO for the department, how many controlling how many projects that can be controlled by the department at the time PNO in several P1, P2, P3. Then automatically convert OR operation. This is another way. Without using the join operation, you can do this one. Nested query. Not much used actually. Why? You need a lot of temporary space for internal query. In this case, only one. What if the output of this one is millions of data? You need to have memory space to keep all this data. So that is the nested query. There are different types of the nested query. In this case, this one and outer query, inner query, you can clearly separate. They are not common. There is no common attribute or table information. You can clearly cut into two query blocks. However, why don't you take a look at this one? Retrieve the name of each employee who has a department with the same first name as the employee. First, you should be able to understand the query itself. Okay? If you cannot understand the query, you cannot make the SQL. So, I'd like to retrieve the name of the employee. I need the employee information. Who has a department with the same first name, okay, as the dependent, like the